the critical thing, I think, is the growth in operational services from the public domain, which have helped us to understand exactly what we can try to do with Earth observations and how useful they can be, but also the growth of cooperation. This is something where we need to think about how do we work with each other? How do we work as national actors, as regional organisations, as institutions, together with the public's big space agencies, but where, very helpful, the commercial satellite industry also. And I think it's a good story so far, but there are many more pages, I suspect, to be written. If I was to give you one more message, it's to remember that in the growth of the satellite service that we've seen, in the Sentinel services, etc., it's how we can help people out there in the field, and how we can be quicker and collaborative in building systems that enable us to get the information to them at the point of need. Our speakers today are many and varied, but provide us a great lineup of information that we can use, ranging from, of course, the Copernicus services and the Sentinel satellites that are at the heart of our new systems, the experience of industry working with emergency disaster, very grateful to colleagues from GMV here, and also perspectives from the International Charter on Spatial Major Disasters, and finally David Moore from our own National Centre for Earth Observation, who will be talking about an example of work that we did for Mozambique flooding from a UK perspective, but working with our international partners. So thank you very much. I will hand over to the team who will take you through the webinar.
Hello, my name is Rima Sandhu, and I'm just going to give a brief introduction into Coordinate and Copernicus. So this webinar is delivered to you today by the NCO, which is a beneficiary of the Coordinate project and is funded by Horizon 2020. Coordinate is an open network with 5 Copernicus relays. We support and promote digitalisation and new business solutions based on Earth observation from the Copernicus programme. We build up and bundle local expertise in the civil use of Earth observation close to the needs and offers of citizens, administration and businesses at a regional level. And we share them with other Copernicus relays, academies and new Earth observation players. Importantly, we also fund projects that foster Copernicus uptake. Copernicus is the European Union's Earth observation programme. It monitors our planet and its many ecosystems whilst helping us to prepare for crises and natural and man-made disasters. Copernicus information services are based on data from a constellation of 6 satellites, and these are known as Sentinels. These are basically measuring devices in orbit that sometimes operate alone and sometimes with sensors placed on the sea, land or in the air. Copernicus then shares this data, which can be used to create different products such as statistics and maps. Copernicus is part of a public service framework, allowing full, free and open access to all data collected. So anyone from scientists, students, entrepreneurs to ordinary citizens can actually use this data. Copernicus provides services in 6 interrelated themes. These are atmosphere monitoring, marine environment monitoring, land monitoring, climate change, emergency management and security, and these all translate into concrete and effective areas of application. As I mentioned earlier, Copernicus services provide information that is free and open. We talked about how to access Sentinel data, DIASes and Copernicus services in our first webinar, which if you missed is available on the Coordinate website. Today we'll be focusing on applications of Earth observation for disasters and the Copernicus Emergency Management Service. The Copernicus Emergency Management Service essentially comprises of 2 components, and these are on-demand mapping and early warning and monitoring. There are speakers from Copernicus and EMS who will be able to talk about these even further. I will now pass you on to my colleague Nishad.
Thank you, Rima. So, Rima just went into a slide talking about the Emergency Management Service. So, a little bit more about that service. So, all the data that is generated for the EMS data is actually available to the public for anyone in the world. So you don't need to be any authorized user to be able to access the emergency data. However, if a specific disaster event occurs and you want it to be investigated by Copernicus, you have to submit an activation request. But that activation request can only be submitted or authorized by a member of I've just had a little link come in. Sorry, it can only be authorized by an authorized user, who are... Each member state of Copernicus has an authorized user, as do the Union Civil Protection Mechanism group. Users from international organizations and requesters outside the EU from countries not participating in the UCPM, aka the Union Civil Protection Mechanism, should contact the ERCC, which may be able to activate the EMS on their behalf. If you'd like to know more about this, then check out the user guide that you can find linked to this page. So, if we look at the actual EMS data access site itself, we can see the screenshot that is in front of you right now. So this screenshot is on the access site. What we're going to specifically focus on is one of the options available, which is mapping, so the one highlighted here. Looking at mapping, there are 3 different options that you can see directly available. The first is rapid mapping. This is where there is a real-time emergency disaster going on. So say a volcano goes off, like in Iceland a couple of years ago. If such an event occurs, once a request is made by an authorized user, data can be produced. And that data can be in the form that you can see here. So this is some of the activation requests that have been made. And if you click onto the individual choices for that activation request, you can find a whole load of information. So here I click onto the request that was made to look into a cyclone in Honduras. From that, I can find that there are a whole load of geospatial maps that are available detailing the activities of that disaster. Next, there is the risk and recovery mapping activation. Now this is twofold. You can either have, you can either request, or rather the authorized users could request information on possible risks. So if an area may have the potential of being flooded, a person who has that authority could request for that information to be collected. Again, that information is then released to the general public. Likewise, if an area has been devastated by something, I don't know, such as an oil spill, then again, if an activation request has been submitted, you can actually have that information collected over a longer period of time, and that information is released to the general public as well. So here, this is the information from the risk and recovery mapping activations. And looking more specifically, I've picked one of the options, the activated options, which was looking at crop changes in Nigeria. Now, this information was released in October 2020, but the information was collected from 2007, so you can see that it's a much longer time period. Finally, on that one option is the web map selection. So you can view activated disasters such as global maps in real time. So if we look, this is just a really lovely, pretty picture that will appear that shows us the actual disaster in action. So here is a global map, and here you can see flooding that's occurred in Tabasco, which is a region in Mexico, and this is all from this live map, well, kind of semi-live map that you can find on the mapping page. As I say, there are other options on this process available as well, such as floods, wildfires, and droughts. Okay, next page. Now that is what Copernicus can provide. There's obviously a lot more as well, but there are also a whole load of other organizations that provide important links into such data. So the first is the International Charter Space and Major Disasters. Their mission statement is to provide satellite data to those affected by natural or man-made disasters through registered organizations for use in monitoring and response activities. I was going to say a little bit more about this project, but we have David Hodgson, who's actually going to be speaking on behalf of them, so I won't say too much more. except that it is a very good site to check out. Next, we have GEO, otherwise known as Group on Earth Observation, their actual title. They are an intergovernmental partnership that improves the availability, access, and use of Earth observations for a sustainable planet. Again, they are a collective whose membership spans both the United Nations and the EU, the EC even, European Commission. Next, we have one of the biggest organizations possibly, which is the World Meteorological Organization, or WIGOS is the one that we're most interested in, which is the Integrated Global Observing System and also their disaster risk reduction arm. As I say, the WMO is a very expansive, wide organization, and so a large amount of their information is quite not difficult to access, but it is very, very, very dense. And so we've created actually a tool so that you can actually find the relevant emergency data information on the site, but I'll talk about more of that in a moment. Finally, there is CEOS, which is the Committee for Earth Observation Systems. Again, David Hodgson, who's going to be speaking, also sits on the board for the Disaster Risk Reduction work group. Now, that is the work group that is really most relevant for disaster risk management, and that is a page you should check out. Particularly on that site, it actually has some amazing resources for anyone who is interested in the field. Along with those four group organizations, there are also a few other places that you can check for information, such as these links towards earthquakes and volcanoes and Sentinel user products and data linked at the bottom there. As I've already mentioned, we have created a PDF manual that helps you go through not only the Copernicus websites, but also these other links that we've mentioned. That will be released next week or the week after. We have also created some YouTube videos to go through the websites themselves. That is all from me for now. Well, I'm now going to hand over to our first speaker, who is Attilio Gambardella, and he is joining us as a representative from the Copernicus project itself. Hello, Attilio.
Hello, thank you, Nishad, and good afternoon. Good afternoon to everybody. Can you confirm that you can hear me?
Yes, I can, indeed.
Okay, so thank you for having me here. I'm very pleased to join this webinar. I will build on the excellent presentation made by Nishad, trying to give a complete overview of the Copernicus program, in particular what is provided by the Copernicus Emergency Service, and then I will hand over to my colleague Jesus, who will give a better insight on one of the components, which is the early warning system when it comes to forest fires. Can you put on screen my presentation, please?
Yeah, hopefully you can see it now.
Okay. For those who don't know me, my name is Attilio Gambardella. I work at the European Commission, where I'm policy officer at the Directorate General for Defense Industry and Space, where we manage the Copernicus program under the Earth Observation Unit. The Copernicus as a whole is implemented in partnership with member states, European Space Agency, the EUMETSAT, the European Organization for the Exploitation of Meteorological Satellites, ECMWF, the European Center for Medium Range Weather Forecast, and agencies of the EU, like the EMSA, European Maritime Safety Agency, and the European Environmental Agencies, as well as Mercator Ocean.
I'm so sorry, Attilio, I think I'm on the wrong page, so that's the front.
That's fine, okay. So here we are. This is Copernicus, the snapshot of the entire system. We have the satellite imagery, which is our space infrastructure. We have in situ reference data. The ground segment of Copernicus is also very relevant. But together, they also are used still by the European Commission and its partner to develop some core services. These are 6. One of these is the European the Emergency Management Service. And the objective is to provide, together with data and satellite information, value-added products, which are all free and open accessible. Next slide, please. This is the This is a snapshot of how the emergency service of Copernicus works. It provides to all actors involved in the management of natural disasters, man-made emergency situation, and humanitarian crisis with timely and accurate geospatial information derived mainly from satellite remote sensing and complemented with all possible available information which are available in situ and from open data sources. There are two main components, as Nihad already explained. There is an on-demand mapping and an early warning system. The idea is to cover all the possible component of disaster risk management process. Next slide, please. Clearly, in particular, when it comes to the emergency service, as I said, it supports all phases of the disaster management cycle and is at European level is clearly linked to the European Youth Emergency Response and Coordination Center, ERCC, which is based in Brussels and as a global overview. And the emergency service is jointly coordinated by three commissioned services, as I say, DG DEFIS, from which I belong, the JRC Joint Research Center, which is responsible for the technical coordination, contractual management, monitoring, and de facto in the delivery of the service, and clearly from DG ECO, which is responsible for the operational coordination, including the interface with users and authorizing offices. Within DG ECO is where ERCC stays. Next slide, please. I will really try to go fast on this next part of my presentation because I say there are colleagues that after me will provide more detailed information. When it comes to the early warning, there are three elements that are mainly focused to Europe, but they are progressively covering, aiming at providing a global coverage. The first one is the European Forest Fire Information System, ERFIS, which provides real-time and historical information on forest fire regimes in Europe, Middle East, and North Africa regions. Next slide. When it comes to floods, we have the European Flood Awareness System, EFAS, which provides overview on ongoing forecast floods in Europe up to 10 days in advance. And it's also very important, I'd like to highlight that in that context, we also, the awareness system is also very active in providing early warnings when it comes to flash flood events with a very short notice. Next slide, please. The last early warning element of the early warning component of EMS is the European Drought Observatory, EDO, which provides drought relevant information and early warning for Europe. For the three aforementioned systems, as I say, they are also linked to the EMS. They're systems run by JRC, aiming at covering, aiming at having a global coverage. And we have the Global Flood Awareness System, GLOFAS, the Global Wildfire Information System, GWIS, and the Global Drought Observatory, GADO. Next slide. The other component of the EMS is the on-the-map mapping modules, which provides on-demand detailed information for selected emergency situations that arise from natural or man-made disasters anywhere in the world. Clearly, during, right after the disasters, we have the rapid mapping, which provides geospatial information within hours or days, depending on the availability of information, on a service request in order to support emergency management activities in the immediate aftermath of a disaster. Following the disaster, we have the risk and recovery mapping, which supplies geospatial information at more detailed level in support of mainly disaster management activities, including prevention, preparedness, risk reduction, and recovery phases. When it comes to next slide, please. This is the portfolio of RAVI mapping. When it comes to RAVI mapping, clearly we also, within last year, we also included a new feature, which is the second column here, excuse me, which is called first estimate, which in the best case scenario can be provided within 2 hours from the request of activation. And clearly doesn't provide the best quality in terms of information, but as a first guess can really be helpful, especially in situations where time is a very important aspect. Next slide. This map only to show you the amount of activation of the rapid mapping services all over the period 2012-2019, which is, I forgot to mention, the EMS is one of the first services activated under Copernicus, and it's fully operational since 2012. Of course, it evolved and improved over the years. I'd like to highlight sorry, that although majority of the activation covers European and EU territory, we have a quite large percentage of activation that look at areas in other parts of the world, giving that the capacity of provide support of these services is clearly global. Next slide. As already mentioned, when it comes to the on-demand mapping, we have there is a very strict and well-defined procedure, which is also linked to the procedures of the Emergency Response Coordination Centers of the EU. We have a list of authorized users that can ask, can demand for the activation of this service, together with, of course, the European Commission and the External Action Service of the EU, meaning that all the delegations of the EU all over the globe can coordinate with us, with the RCC, to demand for an activation. Once the activation request is submitted, there is an internal technical feasibility analysis, and following that, if it is accepted, it happens 99% of the time. There is the process change starts. Next slide. Risk recovery mapping, as I said, it supplies geospatial information in a timing that can span within weeks and months, and it's a more detailed in deep analysis, and is and it's used for clearly for different phase of the disaster risk management cycle. We have next slide. There are two categories of activation of products: the standard here on the right side and flexible on the left side. Standards, I will show you in a minute, a list of predefined products that can be delivered in relatively short times, 1 or maximum 2 weeks. While for the flexible activation, they are tailor-made, and it requires sort of exchange between the entity asking for the activation and the service provider to identify the better configuration, and then the processing of the information. And then in that case, the time to provide the product it's a bit longer. It's 1 or 2 months, depending on the complexity. Next slide. This is an overview of the standard products, and just scroll the next slides, because we have details when it comes to floods. Next slide. Similar for forest fires. Next slide. Again, next slides. We have damage impact assessment, and the last slide of this category is the foreground deformation analysis. This is a portfolio which is evolving over time, and please stay. I invite you to, if you're interested in this kind of service, to look at the portfolio availability regularly because it evolves quite frequently. Next slide. Data access as clearly the entry point when it comes to emergency Copernicus emergency management services is the emergency Copernicus website. Nihad has already mentioned about capacity where to download maps, and also she mentioned that you have images, I don't have. Shame on me about this new viewer that can allow us to visualize all this on a dynamic map the area activation and the products already available. Next slide. And here is just a series of links because clearly when it comes to Copernicus data in general, there are sometimes there is also interest of having access to the space, to satellite data or other, not only service information. And clearly we have the all Copernicus website where there is a free and open access policy, but we invite users to register. When you want added value, you can also use DIAS to request some ad hoc processing of the data you are interested in. Next slide. Clearly, space data are also available by our partner, the European Space Agency and EUMETSAT. And I guess last slide. When it comes to service information, these are the links of the 6 websites where you can access to the portfolio of Copernicus services. Finished. Thank you very much.
Thank you. So that was wonderful. Thank you, Attilio. Are there any questions at the moment from any of our users, or are we waiting till the end? It might be a little bit difficult to try and go through them straight away right now. Oh. Let me just check. Questions? I think it might be easier to go through them maybe at the end.
If I may, I saw there is mentioned that our EMS viewer is actually down. I will inform our colleagues. It might happen because it's still in advanced beta test, so sometimes it's subject to some glitch and hiccups. Thank you.
That's brilliant to know. When it does come up and running, I do highly recommend everyone to go check it out because the maps that it creates are just very beautiful to look at if you are interested. At the moment, because it's quite difficult to gauge the questions from the chat, I will move on to our next speaker. So can I introduce Jesus San Miguel Ayans, who is also from Copernicus, and he, I think, is going to be more specifically speaking a little bit about wildfires, if I'm not mistaken, as well as Copernicus as well.
Yeah, thank you, Nisha. Thank you to the organizers of the webinar and also to all the attendees that are waiting there. I will share my screen in order to allow you to look at the presentation. Okay, very good. So just a very short introduction on myself. I work at the European Commission Joint Research Center. My name is San Miguel Ayans, and I have been in charge of the development of the European Forest Fire Information System, and I am also leading the development of what is called the Global Wildfire Information System. I had included in the presentation a couple of slides on EMES in general that I will skip because there has been a very good presentation by my colleague Attilio and also by Nisha at the beginning of the webinar. So just to mention, there are two components, the on-demand component and the early warning and monitoring. For me, what is important is that you realize often press people talk about activating Copernicus. The activation of Copernicus is really necessary for the on-demand services, but it's not necessary for the early warning and monitoring systems. They are running continuously and they are providing fires
Hi.
continuously. In the case of forest fires, for instance, on-demand mapping was activated 35 times
Ah oui, oui,
in
carrément.
2019, while on
Ah non, parce que j'ai pas vu.
European
Je
Forest
pensais
Fire
que ça faisait pas
Information
longtemps.
System, we mapped over 3,000 fires during the year. So while EFIS is routinely looking at fires in the pan-European region, the on-demand mapping only looks at fires whenever there is a request from a user that is interested in having specific and detailed information on a single fire. I will skip this couple of slides on rapid mapping because this has been presented by Attilio and previous camp recovery. And then I will move on to the presentation of what is called the European Forest Fire Information System. The idea of wildfire monitoring in Europe came up around 1998. We started discussing with European countries, at that time mainly Mediterranean countries, and Finland and Germany, on the establishment of a system that would cover the European region. Because it is not possible to have information on forest fires by the aggregation of the data coming from the different countries. Mainly because the definition of forests is different in the countries. The way in which fires are recorded and measured is different in the countries. So putting information from different systems into a single pot was not possible. The alternative was to create a European system that would work like an umbrella of the national systems, and that is the EFIS. EFIS looks at the data in the whole phase of the cycle of forest fires, starting with fire danger forecast, assessing fire danger before the fires take place. Then we have fire events. We monitor active fire detection, map the areas that are burned by the fires, and once we have the fire perimeters, the areas that have been burned, we do post-fire damage analysis, looking into land cover damage, emissions assessment, potential soil erosion, and we close the loop with the analysis of vegetation regeneration. The system is an open system, different from, for instance, the European Flood Alert System. That is a closed system that provides alerts to registered users. In the case of EFIS, everyone can access the information. And you can access the information just directly through the viewer, or you can request the information as Attilio presented through the data request for all data access. In terms of online information, that is provided by what is called the current situation viewer. And the information you have there is information on fire danger before the fires take place, and then information on active fires, burnt areas, and statistical information on the fire campaign in the pan-European region. For fire danger assessment, we use in EFIS what is called the Fire Weather Index. The fire danger assessment that is provided by this index gives you information on the easiness for a fire to ignite, and then the probability that that fire that has been ignited will progress. So the higher the fire danger, the higher the probability that an existing fire will progress and become a large fire. And we use two models currently, Meteo France and ECMWF, and provide a series of indices. Then the next part that is in EFIS is the active fire mapping. And active fire mapping is processed through two different sensors. One is MODIS, both of them coming from NASA. We are about to incorporate Sentinel-3 that is coming from Copernicus directly. For now, what is in the system is MODIS. It has spatial resolution of 1 kilometer. These are the fires that burned in Portugal in 2017. Then we can add the information on VIRS. The difference between MODIS and VIRS is MODIS is 1 kilometer spatial resolution, while VIRS is 375 meter resolution. MODIS is on board of two satellites of NASA, Terra and Aqua, and VIRS is on board of the Suomi satellite. So in total, they provide 6 times a synoptic view of active fires on Earth. The collision error of these sensors is very low. So the fires that are detected, there is a very, very high probability of 95% that are real fires. Then we do the mapping of burnt areas. In EFIS, the mapping of fire perimeters, burnt areas is done twice a day, although the system is updated more frequently. And once we have the fire perimeters, then we can first assess the severity of the fire. The severity of the fire is assessed by comparing the pre-fire conditions of the vegetation to the post-fire conditions, and then determining the decrease in the spectral response of the vegetation through what is called an index that is called normalized perforation. And then finally assess the land cover damage in terms of vegetation to the different land covers. As I said, there is a section in which we provide statistics of number of fires and burnt areas for the countries, and then we monitor the evolution of the fire season throughout Europe, in each country and in the European Union as a whole. This was the state of the burnt areas in 2017, in September, and that was just before the very large fires that occurred in Portugal in October 2017. But this information is updated, as I said, twice daily, and then the graphs are updated on the site every week, and the data can be downloaded. The network of countries to which data provides EFIS, to which EFIS provides data, and the number of countries that are also providing data to EFIS is 43. And as you can see, they cover the pan-European region, is Europe, Middle East, and North Africa. Then I will move on with what is called the Global Wildfire Information System. The technology that we are using currently in EFIS is mature enough to expand the size of the system to the global level. When EFIS was started the first operation was in the year 2000, it was really unthinkable that a system like that could ever be built at the global level. But now the sensors we are using, the information that we are using for fire danger assessment is available globally at least on a daily basis. So the idea of GWIS is to follow the same scheme of EFIS, but then to provide the information at the global level. As different from EFIS is that EFIS is fully under the Copernicus umbrella, so it's supported only by the Copernicus program. In the global system, we started the development with the support of other partners. Two important partners of those are the Group on Earth Observations, which is an international organization that has partnerships all over the world, and then the NASA, the Aeronautical and Space Organization of the US, that is funding projects that are supporting the development of a global wildfire information system. Finally, but very important, is the support of what is called GovSeaGLO, which stands for Global Observation of Forest Cover, Global Observation of Land Dynamics. This is a network of experts that have been developed remote sensing products especially from NASA sensors, and then they are the top of the we can say processing chain of remote sensing for fire products, and they are a network that is supporting the development of GWIS. The system is very similar. So if you look at this is the Fire Weather Index computed from data from the European Center for Medium Weather Range Forecast. The data is exactly the same as the data that we provide in EFIS for Europe. So eventually it may happen that the EFIS becomes a window of what is now the global system. And this information, as I said, is updated daily. And we are currently using 3 models, in 2 models, the European Center for Medium Weather Range Forecast, deterministic, the probabilistic, and third model from NASA. And we provide exactly the same indices and sub-indices are provided in EFIS, including, for instance, the Mark 5, that is the Australian, or the National Fire Danger Rating System, which is used in the US. Then in the section of rapid damage assessment, we have the same technology that we have in EFIS. So we have the mapping of active fires using MODIS, and this is for the last 7 days, for a week. And then the mapping of active fires using VIRS. VIRS is much more sensitive to differences in temperature and can detect smaller fires than MODIS. So these two types of information, MODIS and VIRS, are used to map in real time fires globally. And that is what you have in the system called MODIS and VIRS near real time. And this service that is provided globally that we are currently using to monitor wildfires in the Amazon region, in all the countries in the Amazon, but has been used in many other countries, and I will show some examples. The areas that you see here in white, wherever there is a white circle, this is an area in which there is a fire of at least 10,000 hectares. So you can see the concentration of fires in the Amazon, in Bolivia, Paraguay, in California, in Central Africa, in Indonesia, and in Australia. So the areas that were most affected by fires this year were California, and you can see this has been practically the worst year ever, not in terms of human casualties, but in terms of area burned in California and the western coast. Then we have Brazil. Brazil is currently at around 50% higher in terms of burned areas as compared to last year. And last year was a critical year in Brazil. And all the countries in this area, from Colombia, Venezuela, Peru, Bolivia, they are all above the figures of the burnt areas in 2019. In Australia, we were providing from GWIS near real-time information to the Australian authorities during the fires that happened in December 2019 and early into 2020. In the problem in Australia were the fires in the southeast that affected the areas that were heavily populated, as opposed to the traditional fire areas in Australia. Then, as I said, the fires in Asia, and then also specifically in the Arctic Circle. And this map was specifically prepared for the Emergency Response Coordinating Center, just to demonstrate, to show that the number of fires in 2020 and the areas were much greater than the areas in the previous years. Then, in addition to the data that you can find online in GWIS, we are building what we call GWIS country profiles, which will contain, they will be launched before the end of the year, and they contain information based on time series of remote sensing data for fires from 2001 until 2019. And there you will find information on burnt area, number of fires, the seasonality, and then you can look at the fire size across the different sizes of the fires. Burnt area land cover, seasonality in the last 22 years, land cover damage, the evolution of a given year in terms of land cover damage, etc. That is for multi-year charts. Then within a year, you will be able to analyze similar information on the seasonality, the burnt area, and the fire size, the land cover damage by fire, the fire size and the proportion of, for instance, it is important to know that around 3% of the fires in Europe are responsible for around 80% of the total burnt area. And the same thing happens in many other countries. So here in this chart, you can see that most of the fires are small. But then, for instance, fires above 1,000 hectares are responsible for nearly 70% of the burnt area. And then finally, spatial information on the seasonality of fires. So monthly burnt area, in which you can select for a given year the area that is burned on a given month, the cumulative burnt area on a given year, the fire frequency, and the median day of burning that gives you the distribution of the burns across this year. And additional information will come also from land cover damage to protected areas by using what is called the World Data Database on Protected Areas. And finally, what will be added in GWIS also this year will be something very similar to what is available in EFIS. Looking at the seasonality, these plots are updated weekly, which will allow to monitor the fire campaigns in the countries globally for any country. So it will be administrative level 0 or within a country at administrative level 1. Land cover damage and also evolution of the fire danger as compared to previous years, using what is called the daily severity rating. I think with this, I just summarize the type of information and services that will be provided by GWIS, which are aimed at really providing capacity, supporting capacity building, and providing systems that are not existing in many countries across the world. And with that, I would like to thank you for your information and for your attention. Thank you very much.
Thank you, Jesus. So we've actually had quite a few questions that have come through. Now, we're actually short on time at the moment, so we'll answer one question. I'll put one question towards you, if that's okay.
Yes.
And we will try at the end to fit in all the rest of the questions because there are so very many. So this question, I won't say the person's name, I'm not sure if they want that, but the question is, hi EMS, what is the fire danger verification model and the outcome of it?
Yeah, the fire danger is calibrated on the basis of a number of fires on fire size. So what we do is the fire danger is provided in several segments from very low to extreme. And then the numbers of the fire weather index in the extreme value correspond to fires of a very large size. So the range of fire size and intensity is calibrating the values and segments of the fire danger.
Thank you. So as I say, there are still further questions for you, but we'll try and get to them at the end. We're going to have to move on to our next speaker because we're short of time. Okay. So is Antonio about? Antonio? And
okay, thank you.
And just so that everyone knows, yes, all the recordings and the PDFs will be shared as well from all the speakers at a later date. You'll find more about that in your emails. Is Jesus there? Not Jesus, is Antonio there?
Yes, I'm here.
Perfect. So Jesus, you're still sharing your screen. If you can unshare, or alternatively, Antonio, you can start sharing and it will automatically take over.
I will do it.
So Antonio Tabasco Cabezas is from GMB and he works at Copernicus and data, and you're going to be telling us all about it. So welcome, and I'll leave it to you.
Okay, thank you. Let me see if I can set the screen. Okay, this one. Now you should be able to see it. Can you see it?
Yes, and also I should just say time is a little bit short, so go for it.
Okay, thank you, no pressure. Okay, so I will focus my presentation on providing a different view of the services that are provided in the world of emergency and disaster, in this case from the industry. What I mean with this, it was really challenging at the time of preparing this presentation to prepare material to be displayed and so because it could be at the same time presented by the other colleagues from the panel, because they are in fact the institution managing the emergency and disaster, but we are also active in other areas. Just to summarize, I'm Antonio Tabasco. I'm the head of the Division for Remote Sensing and Geospatial Application, and at the same time I'm acting as a Copernicus relay in Spain, one of the few industries acting as Copernicus relay. So I have prepared my presentation focus on two different aspects. The first one is just providing some examples of activities that we are doing, trying to avoid repeating about floods or fires. And the second one is regarding our experience as industry providing these kind of services. So just to underline that we are using Copernicus imagery, Sentinel-1, Sentinel-2, in this case for delineation of flood events, using both optical and radar data to extract extension of the floods, also providing damage assessment maps, using photo interpretation in this case. I will talk about this point of the photo interpretation later on, because from the point of view of the industry, it's also quite a complex issue. Here we are using very high resolution imagery for the delineation of the damage assessment. But we can also generate other kind of geospatial information. In this case, for instance, we provide estimation drive time to reach a specific facility, the airport, from different areas of a city that is under a critical situation. So we can provide any kind of services depending on the specific request. More specifically, I would like to focus on the point of the humanitarian aid that linked to the emergencies, because this is quite an important issue as well. Basically, the point is whenever there is an emergency, normally people need to displace from the point of the emergency to safer areas. So we have the IDPs, the internally displaced people, moving from one place to the other. We need to monitor the movement of these people along the different routes, identifying river that are perennial or not perennial, already populated area, vicinity to health infrastructure close to those areas, because these people is moving, these people need to eat, these people need to sleep, so, and they are also co-living with the people that is already living in those routes, so we need to monitor all these points. At the same time, we are providing services in the ADP camps that can grow spontaneously, or they can be organized camp, but we see that the affection on the areas surrounding the camp is quite evident, and it's, well, mostly all the vegetation around the camps is destroyed along the time. With this, I wanted to focus on the trends or challenges that we are facing as an industry in the provision of services in emergency. The first one is the use of machine learning. Well, machine learning has been here for a long time, no surprise on this. The point is that right now we need to provide services as soon as possible and with the highest quality. Here is where we come with the main challenge. Machine learning is quite good, but we all need training, need a lot of input data, need a lot of calibration. Also, deciding which is the best methodology that can be applied is also quite a challenge. But at the same time, we cannot rely at all, well, not at all, we cannot rely only in the use of photo interpretation, because we need to generate information. We already saw that the emergency management system, they are using rapid mapping, they are providing rapid mapping services, so we need to provide information on a quick way, but also quality information. So this is one of the greatest challenges that we have. Here you have oil spill detection. Maybe you cannot see it well because of the presentation, but here is the detection of the oil spill. And here we applied the results from medical image segmentation to the Earth observation world. This is just an example. The second trend that we see is the growing use of Earth observation services supporting climate resilience. Why? Because in the different phases of the emergency, we have that the prevention and mitigation is one of the preliminary and most important phases. So we need to be ready to deal with the aspects coming from the climate change. And for this, working towards the increase in the climate resilience is critical. So the stakeholders are requesting evidence that they can use for the definition of policies and plans to improve the resilience. In this sense, what we are doing, for instance, we have been working in Monrovia, providing monitoring of the impact of climate change in the coastal areas, based on 3 different services, integrating information from already available geospatial layers and also from Copernicus satellites. We have been working as well in Somalia, providing drop indicator. Here, the critical point to me are the figures. As you can see there, 800,000 people moved from their homes, searching for water and food. So this increased the number of additional services that need to be provided. This increased the action from the international funding institutions looking for supporting these people, so it's quite an issue. In this example, you can see the index developed, applied from July to August, and you can see the increase of the drought. Another challenge in this case is the integration of information from different sources. All the information that was presented here comes from layers that are already available. Global Human Settlement is a climate change initiative, the OpenStreetMap, Copernicus imagery, very high resolution commercial imagery. But which is the problem here? The problem is that we are working with a lot of information, good quality information, but that is provided at different level, different scale, different periodicity, and it requires a huge effort in the fusion of the information and in the downscale of the information to go regional and local, because the problems are really at that scale. They are not, I mean, you can always do the analysis at a national level, but normally the problems are presented at the regional or local level. So finally, for the conclusions, the good point is that Europe has become one of the largest providers of good quality services, and this is great for everybody because the information is there and it's already proven and validated. The problem that I said is that we need to put everything together, and it's a good opportunity also for the industry in order to work at the proper scale. Another problem is that the extension and the duration of the crisis has changed, unfortunately. So now it requires the processing of a large amount of information. So photo interpretation is no longer the only solution. We need to provide additional solution like big data, machine learning. Any kind of solution that can be used will help. And finally, from the point of view of the industry, it's also evident that we cannot keep the pace in research and commercialization. So from my perspective, and this is the good thing about the Copernicus Relays and the Copernicus Academy, both worlds, industrial and research world, need to collaborate together to be able to deal with these increasingly demanding requirements. And that's all from my side.
Yeah, that was a wonderfully concise talk. I loved it. We've got a question for you. It's as follows. I have a question on oil spill detection by ML through medical data. Does this have a precedence or a supporting research of which results can be validated? What guarantees the usability of the rehash?
Well, the point, of course, we have the results from the literature in terms of image segmentation applied to the medical world. But then if we move this methodology to our area, we need to validate it. So we have already run validation campaigns because we have been already participating in the past in a number of different campaigns involving the use of maritime detection and oil spill detection.
Perfect. We've got one more question, which we'll quickly go through. What is your strategy to go from global level to local, regional level?
Well, that's a good question, and that's the problem. I mean, the point is that whenever we use the global geospatial layers that are already available, they are provided normally in a scale of kilometers or hundreds of meters. And if we want to work at a local level, we need to work in the area of thousands of meters or meters. So for this, we normally integrate information using enlarging the pixels and approaching to them as superpixel classification. And also at the point of integrating the information, we need to look for the proper value. I don't know if you're aware, but there are different standards for the visualization and organization of the information. So that we try to move from the imperial measurements or metrical measurements to coordinates in terms of grids. And this is one initiative that is quite trending, and a lot of people is going toward this.
Perfect. Well, that was fantastic. Thank you, Antonio.
Thank you.
Going to be moving on to our next speaker now, and that is David Hodgson, who is from the International Charter Space and Major Disasters. David, are you there? Yes, I can see him.
Yes. Hi, Misha.
Hello. Feel free to present whenever you're ready.
Thank you. I'll just bring up the presentation here.
And again, just to remind everyone, if you have any questions and we can't get to answer them right now, please do still put them into the chat. If it's for a speaker who's already spoken, then please put their name in and we will try and answer them at the end.
Okay, can I just check that the slides are visible?
Yes, they're perfect.
Fantastic. Hello everyone. My name is David Hodgson. I am, as has been said, I'm an Executive Secretariat member for the International Charter for Space and Major Disasters, which we very often refer to as the Charter or Disasters Charter for short. What I'm going to talk about today is just an overview of this other mechanism for accessing space data for emergency response. I'll briefly touch on how that contrasts a little with the Emergency Management Service, which we also have a very good and strong cooperation with. And finally, very briefly, touch on the CEOS Working Group for Disasters, which may also be relevant to some people listening today. So, first of all, we'll have a look at the International Charter, and the International Charter is really focused on one thing, and that's providing satellite imagery for emergency response. It came together 20 years ago. It really was realized to plug this gap in accessing satellite data rapidly for emergency situations, and over time has grown into a very large and global service to do just that. So as I said, it's priority access to the satellite imagery for the space agencies and satellite operators and providers that work within the Charter. It's predominantly run by space agencies, but our community is much wider than that. You'll see on the slide here a list of all the satellites that are available through the Charter and that satellite data. So just to reiterate, what we're talking about here is satellite imagery itself. So if that's something you're familiar with, it's the lower level, level 1 geolocated products, but it is the basic satellite imagery, so not mapping products that come from the Charter. It also is for disaster response, and what that means is that it's that time period where particularly the civil contingencies and emergency management agencies are first responding to the disaster, and an activation for the Charter typically lasts approximately 10 days. We do extend that time on occasion, but that's commonly the time scale we're talking about, that 10 days after an event. And the data is provided for free. As we said, you can see all the satellites available here. Not only do we task new fresh data, but we also provide access to the data from multi-year, multi-mission archives. And as we said, that data is processed for you, but at basic satellite imagery levels. So as we've said, the Charter itself, over 20 years, we respond to approximately 40 activations a year, and across the globe we have 81 authorized users and growing week by week. An authorized user is the mechanism by which we allow access to the satellite data. So it's demand-led. An authorized user must request the data, and these authorized users are pre-approved, and we tend to work with civil contingencies and agencies that have a role in emergency response that will utilize geospatial data in some way. I think that probably covers the main points on the Charter. The website, there is a link at the end of this presentation, has a lot more details. So I would encourage you to visit that site to learn more, and you'll see the details of all the activations that we have responded to, and obviously the ones that we're responding to currently. A few words on maybe a contrast with EMS, which you've heard a lot about today. The Charter, as we've said, is about satellite data, so we don't provide mapping products or information products, and it is for emergency response, so not for risk mapping or monitoring. Those activities are much better covered by services like EMS and others. But I would highlight the fact that there is a very strong and ongoing cooperation between the Charter and EMS, among others. We are on occasion will provide data to the Emergency Management Service, and the Emergency Management Service will on occasion provide mapping services for Charter activations for authorised users that may not have access to that capability and service. So this is something that we do regularly, and we coordinate amongst ourselves and a wide number of other organisations, especially when there are major events. So Hurricane Irma was a particular sort of a key event, I think, there for many of the emergency response and mapping and risk mapping organisations coming together and actually coordinating to optimise the activities. As we said, imagery from the Charter, mapping and other services from EMS, and there is a strong existing cooperation. I will touch finally on another activity that for some may be of more relevance. So if you're not a national body with a mandate for emergency response that the Charter primarily deals with, maybe you're more involved with research or science activities, then you might find the CEOS Working Group for Disasters equally interesting. The CEOS is a large organisation. It has 61 space agencies with a very wide variety of satellites deployed for many purposes, but many that we're familiar with and many that we're not. And its objective really is to see Earth observation best used, and it coordinates across the agencies to kind of optimise the use of Earth observation satellites for all sorts of purposes. Now, there is a working group dedicated to disasters called the Working Group Disasters. A number of the space agencies work regularly and routinely within that working group, but the working group itself spreads a lot wider into a much wider community, particularly for science and research, and it supports with data from a large number of the space agencies' missions on an ongoing and more comprehensive basis, providing access to satellite imagery within projects, and the sorts of projects that the working group has currently include a geohazards lab, a volcanoes pilot project, a recovery observatory, which is basically looking at post-disaster needs assessment and recovery activities, and activities in landslides and seismic hazards. So these are specific projects, but they're very large, they're global, and incorporate a wide variety of stakeholders under the umbrella of these projects that CEOS supports. So you may find a project that's relevant to you that you could participate in, or there are other ways to get involved. But certainly, again, I would draw your attention to the website for further information, and encourage you to visit the Charter website, which, as we've our other speaker, the website's been upgraded today, so I think there are a few access problems currently, but give it a little while and that will be back with all the information that you need. So I think that's, as we're a little short for time, I think that's probably all I wanted to say today. The Disasters Charter is for rapid access to satellite imagery for emergency response.
That's perfect. Thank you, David. We won't have any questions unless there's some at the end, because yes, we are now really running short of time. I'm going to introduce our next speaker, and it's our last speaker. It's David Moore, and he's going to hopefully share his presentation in just a moment. I would also just like to add, from David Hodgson's side, for the International Disaster Charter website, it's got a lovely infographic on activations, on how activations for emergencies work and how data is received. So go check that infographic out. Right, hello, David, are you there?
Hi, Nishad.
Brilliant, perfect. I'm going to hand over to you without much further ado. There's not very much time, so good luck.
Thank you very much. So, Nishad, can I just check you can see my presentation?
Yes, perfect.
Yeah. Brilliant, thanks very much. Okay, hello, everyone. Yes, so this is sort of looking at a response that we did as the University of Leicester NCO work, looking at Mozambique flooding in 2019. So this is a work of a few of us here at Leicester. Myself, David Moore, John Remedios, James Wheeler, Robert Parker and Pedro Rodriguez. Okay. So I shan't go into too much detail about the event itself, but this was one of the worst tropical cyclones that ever was recorded in Africa. And we were approached, this is NCO, were approached by the UK government for Department for International Development, DFID as it was then, to provide some sort of quick response and expertise in using satellite data to monitor the extent of this flooding in Mozambique. So what we tried to do as a group was not try and reproduce as such what the Copernicus EMS service was doing, but used it for guidance. So we were looking at local regions which the government had asked us to look at in particular. So I'll show a few examples later. But we also wanted to recommend other expertise from the UK, such as the Environment Agency at the time. And what we did with our information was, with hope, was to try and prioritise what we were doing in the relief effort from the UK to the local population. So I shan't go through all the details of the cyclone, but one of the issues, what you can see is not our map ourselves, but in red sticks of flooding, and what you can see is this such an extent across Mozambique itself, of the flooding itself, and one of the system was so intense, and it's over landfall for so long. This is why we saw the severe flooding and why the charter was activated. So I say we had quite a small team, but we sort of came together very quickly across NCO to come together and look at data that were provided from the charter, and also the sort of non-commercial satellite imagery as well from the Copernicus setup. And we looked at detailed flooding maps across the areas of Chinde and Buzi in Mozambique. So what we actually show is we did focus on using Sentinel-1 because we had the most expertise in this at the time, and it gives quite good spatial resolution. I shan't go through the details because of the time. But we get quite good coverage over Africa. We get 2 to 4 day returns over Africa with the instrument itself. And this instrument itself is fantastic for flooding because it looks at change over land over time, and the data are free. So again, we'll go through some of the techniques, which you may be familiar with. But if you're not so familiar with the Google Earth Engine, I would suggest, if you're using Sentinel-1, that's a good place to go to try and plot your data. So you can code in JavaScript, and you can run through data sets. Don't have to download them, they're all on the Google platform. And there's a lot of details here at the bottom, again, which I shan't go through, but a lot of the data are already pre-processed, which means that the user themselves doesn't have to actually go through that process. The data are ready to use. So we took that data and we ran it through our algorithms that we had developed already for other applications here in the group. And it's a very simple approach. We sort of do this sort of change approach. So you look at the event before and after a flood, and you can produce sort of difference maps using thresholds that you've derived yourself. And the beauty of Google Earth Engine is that these results are shown very quickly because you don't have to worry about downloading data. You can save the plots, download the plots, modify them as you will. But one thing we hadn't actually looked at the time for this, which you could look at using other things to sort of get rid of your filter detections in the analysis. So you could use things like the surface water masks to mask out water that's already there, and also digital elevation models, which would remove slopes of mountains where you wouldn't expect the flooding to be. So that's pretty much where we were. We had some tools in place, so we were okay. We could respond fairly quickly to this. So this is an example here of flood mapping extent with Sentinel-1. This is over Boozy. We also had some expertise in Edinburgh that we could call on that we looked at. So these plots on the left-hand side, you can see.
Okay, I'm just going to stop you there for a second because your screen has went into something else.
Ah, has it?
Yes.
What's happened there?
Load it again, and that should work. Hopefully. Otherwise, I can upload it, and you could tell me to share.
My presentation seems to have disappeared.
It happens. Right. So.
So if you have that, Shad, you may need to.
There we go. Here we go. You can probably take control of it too. Sorry about this, folks. Just be uploading. There we go. It's coming up. Can I just remind everyone while we're skipping through these slides to remember to fill in the feedback form whenever you receive it. Right, David, I think you could take control again.
Okay. Okay, so you can see. So what can you see at the moment? So let's go forward. Okay, so should we receive mapping flow extent again with Sentinel-1. So this is again this Boozy region, and just wanted to flag up what we could do, and you can see the whole area in red was inundated. Okay. Was inundated with water.
I'm taking control because it's not changing with yours.
Oh, okay. So we're on slide 8, is that okay? Okay, so Nisha, can you see slide 9 now? Yeah, okay, great. So this is also in Chinde, region of Mozambique. This is a little bit further to the north of where we were looking before. And again, we could produce these maps over the region, and we could see huge swathes of the region were covered with water. I mean, we were seeing also some little bits of perhaps false detections. You can see here these dots of water. So again, but this is a very quick response, so we were very happy with what we could produce in the short amount of time on the data. Okay, so one of the most important things I want to get onto is really, from user perspective, what we've learnt from this event. So as a team, we were very, very pleased with how quickly we could actually put people together and work on this problem. It did require staff to move away from other projects. We aren't exactly, we have some flexibility in our model, so we are able to do that. And also availability of staff is something we need to sort of consider for future work, but we were very happy with who we had available at the time. Contributions as well. So as I say, it did take some time to work out what we could do as an NCO itself to contribute what we could do. So also we need to account for what's going on in Copernicus EMS, and we need to make sure that this sort of network can be developed between ourselves and other entities, so we're not reproducing effort. And also wide system capability. So when we first looked at this, we weren't actually sure what we should necessarily be looking at as a group ourselves, and so what other groups could contribute.
Sorry, it's not moving through. Should I just click the size? That's what I was doing. Sorry.
Oh, thank you.
I'll just click them for you. It's fine.
Thanks. Sorry, on number 3. Okay, so if we can move on to the next slide, please, Nishad. Okay, so also the platform for data and tools. So what we found, we did have some of the expertise here to produce things in Google Earth Engine, as I mentioned, and also some of the knowledge of how to look at the sort of the finer details of street level and street maps. We hadn't actually anticipated these sort of events before, so getting some sort of knowledge of what we could look at in the future, so sort of almost like training before the event happens, we would like to do. So we've also looked at using the Disasters Charter, which is a really great platform for us to be able to access data. We probably want more than one person in the future to be able to access this because it's almost like a single point of failure. And download speed was a little bit slow at the time, we noticed, the data. And also it's more locally, we should look at having a space to store it. So this is also a key effort. This is the team effort itself in future. How do we sustain this sort of effort beyond 3 or 4 days? Because as I say, we're a distributed centre, but it's trying to maintain the effort, but also to have some impact of that work. Okay, so for the future, there's a few points here. So capability development, I won't go through them because of the time's getting on. So maybe we should just scroll through them, please, Nishad. Yeah. So, yeah, so I will say a couple of words. So mainly for 3, the improved preparedness for these future projects. It's going to be a case of, as a group, I think, just trying to work through what we can do in the future and some sort of upskilling ourselves into some of the work we can do there. The coordination as well, that's something, because it was a new event to us at the time, or a new way of setting up, we wanted to make sure that we weren't reproducing work, so having that the feed into other networks would be something for the future. I do want to flag up the last point, NCO Assist. So what we're doing is moving the HQ of NCO to the new space park here in Leicester in early 2021, and we're trying to design a system at the moment to sort of as rapid response system to be able to look at these events again in the future. So we're very keen to work with other stakeholders in setting up this system, and this is at the moment. So with that, I think, Nishad, I will leave it there. Thanks for your attention.
David. So that was David Moore. He is our final speaker for today. We can go back to some questions that were previously asked by members of the webinar. Thank you to all of our guest speakers today. I'm also going to now hand over to Svetlana, who is the organizer of this event. She's the person in charge of putting it all together. So, Svetlana, are you there? And also, sorry for the technical issues. This is, of course, live and things like this happen. But all of the presentations will be available to everyone in PDF forms in Technicolor. Svetlana?
Hi, Nishad. Can you put that slide up for me, please?
Sure.
Yeah. So we have just a couple of minutes only. And first of all, I will switch my camera on. Hello, everyone. I'm Svetlana. I'm from NCO, which is the UK National Centre for Earth Observation. And we organized this webinar as part of the Coordinate project. And it was really quite an interesting event, and I want to thank everyone who has joined today. And we had over 100 participants on the webinar, with almost 200 registered participants. And this is basically thanks to our panelists that represent such a wide scope of organizations and authorities dealing with Copernicus and emergency management services, and from different aspects, scientific, organizational, and we've heard how difficult the different organizations are working, how difficult the organization is, and how they work together and coordinate between each other. So I hope that the panelists are still there, and there have been a couple of questions that I would like to ask. So if you unmute yourselves. So there's a question about, we've heard a lot about forest fires. So how do you actually make that authorities that are responsible for managing the forests are aware of this data? So what is their strategy so that they make the best use of them?
Yeah, well, all the data are available directly on the system, on EFIS, which is widely known. But in addition, we have a network that's called the Expert Group on Forest Fire. that includes national representatives of the different countries, as I mentioned, now 43, that are in charge of disseminating the information within the countries. Then annually we publish an annual report in collaboration with the countries. That is as regards the national fire management authorities. Then we also have the Copernicus Committee and the Copernicus User Forum, which are also two additional networks that allow the distribution of information and data on the system.
Perfect. Svetlana? Or is anyone else going to follow up?
Thank you, Jesus. I have another question, and that's about the quality of data. Antonio, I think you mentioned how difficult it is to integrate the data from different sources. So the question is, how can we say that the data we get from these services are really high quality? Is there a guarantee that they are actually state-of-the-art data?
Well, in principle, the geospatial layers that are already served by the European Commission are public, and the validation process is available. So the quality of the data is confirmed. In fact, there are open calls for the validation apart from the ongoing project for the generation of the data. So validation runs in parallel with the generation of the data.
Okay, thank you. So there was another question, but I can see that it was already answered in the chat, and that was about APIs. Mm-hmm. Does EFIS or DVIS have APIs? And they are available.
Yes. Yes, they are available in case they have any problem in accessing the data. Just contact us. I put the contact point there, and then we can help them.
Okay, there's another question, I think, and that's about danger, fire danger, because it's clear, we've seen today that active fires and burned areas are clearly mapped from satellite data sets. So are there any plans to integrate those observations into fire danger mapping?
Well, the fire danger index that we are currently using in EFIS, is the fire weather index, is purely meteorological. It does not include additional information that could be included in the fire danger index, such as the vegetation index or the fraction of photosynthetic assumption by the plants, which are often available in drought indices. The feedback we received from the countries is that vegetation normally takes some time to react to sudden changes in meteorology. So for the fire management authorities, it is more important to look at these sudden changes than to wait for a response of vegetation. So they are not, this Earth observation is not included directly in the index that is used for fire danger, but it is observed for the evolution of the vegetation during the year.
Okay, thank you. Well, I wish to thank everyone for staying over time, and hope that if there are no urgent questions.
We have a few questions that we have left over from for Jesus. Shall I go through them?
Yes, if you have.
Okay, so Jesus, you had a question which was, active fires and burnt area are clearly mapped from satellite data.
I've just asked that.
Sorry. Is there any on the product quality check? How can you guarantee they are active?
Yes, thank you, Nisha, for the question. We have done the validation of the fire data in EFIS throughout the years, but the data are changing continuously as new satellite data become available. So we are currently conducting an evaluation campaign of both EFIS and GWIS through the EMS validation service. So that is one of the mechanisms. Another mechanism, although it is not strictly a proper validation, is the feedback from the countries. So countries are using the data in EFIS now for quite a number of years, and then we receive feedbacks from the countries if there are significant errors in the mapping, or if there are, for instance, omission errors, areas that have not been detected and mapped. So those are the two main channels for evaluation and validation of the data.
Thank you for that. Yeah, that's the end of those questions, because Anna's covered all the others.
Yeah, I think we can now successfully close this webinar. And I just remind you that we have a very short anonymous survey, and the link is now. Please just go and spend 2 or 3 minutes filling the survey. And hopefully, when we have our next webinar, we'll see you again. Thank you.
Thank you.
Thank you. Bye-bye.
Bye-bye. Thank you.
Bye.
Attends, j'arrête.